Hey, this is T Band, and this is my third part in a Flat Earth series. And my first part was about an introduction to Flat Earth a little bit, um, and some arguments for and against it, that I thought would be beneficial to anybody starting to study the Flat Earth. And the second part of my Flat Earth series was about some practical experiments that many people would be able to do in order to gather some information about the nature and shape of the Earth, its position, and whether it moves. This part is a little bit different, and I'll be going on memory from a lot of this. Now, I've heard it said by somebody that getting interested in the flat Earth and learning about it is a great resource for educators, that it's an interesting subject with ties to many branches of science, including history, geography, cosmology, mathematics. And in this one topic, there are many areas of science that it touches. And for a person that wants to spark interest in students to be active in learning the flat Earth and researching the flat Earth is a very good starting point. Now, I'll just go from memory and talk about some of the things that I've come across about the flat Earth, and mention some people and names. You'll learn about some of the early Greeks and their views on the shape of the Earth, and that gives an introduction to Greek language. Words such as stadia and climb, like climate, CLIME. The climb is what latitude you're at. So there's Eratosthenes, and he put a pole in the earth. And there's the place in Egypt called Syene, I believe, Syene, where there are wells that are plumb, and they go straight down. And you can build a well straight down without getting off track by hanging a lead weight or a heavy weight. Lead is the Latin word plumbum, and that's where we get the idea of a plumb line, which is a heavy weight that hangs. Usually it has a little point at the bottom, and it hangs from a string, and it will guide your development of structures that are vertical, away from the center of the earth. There's the Greek church father, I believe his name is Lactanus Firmianus, and he talked a little bit about the earth being flat. And then there's the Greek-speaking person who lived in Egypt, I believe. His name was Cosmos Indicopleustes, and he was a world traveler, went to India. That might be reflected in his name. And maybe in the 400s he wrote a treatise about his travels and his views on the flat Earth. And he may have written other books also that have not survived to this period. Now, during the Dark Ages, or what are known as the Dark Ages, we may have had preachers that did believe in the flat Earth, and and taught the flat earth. That doesn't mean that there weren't other people in the scientific community, like in universities or colleges at that time. They also may have, from their studies of Ptolemy, had a view on the earth, and their view being that the earth is a sphere. Now, it's believed that Christopher Columbus thought the earth was round and that you could get to the east by sailing west. But even in his days, there would have been some flat earthers, because he had to get approval from the scientific community, which at that time there were a lot of religious leaders who were also the heads of colleges. And some of the religious leaders or educators or scientists in the time of Columbus, we find from reading a book by Washington Irving about the life of Columbus. Now, Washington Irving had actually traveled in maybe the early 1900s or 1800s, had traveled to, I believe, Portugal or Spain, to Salamanca, and looked at their records firsthand, and found that there were some people who opposed the belief that Columbus could get to where he was going by sailing west, by making the argument that in the Latin you have the word, Latin Bible, you have the word pelum, or skin, or tent, or skin, for tents, that the heavens are stretched out as a tent in one of those psalms. So that's a flat earth argument right there. And so not everybody in the time of Columbus actually believed that the earth was a sphere, even though many in the scientific community did. The flat earth was presented as possible by a man named Samuel Burley Robotham, and he went around England in the 1840s and 50s maybe, and he early on was impressed with Sir Isaac Newton, as were many people in Europe and England. Or if he wasn't impressed with them, he was around people who were. But he felt that Newton's view of the shape of the earth was in opposition to the Bible, and that it was a point of victory to the people that rejected the Bible, that the Bible's teaching of the earth is not what modern science was showing. Samuel Burley Robotham went on lecture tours all around England, and at that time there was a class difference between the wealthy class and the working poor class, and the nobility and the poor. And you'll learn some history and what society was like at that time just by learning about Robotham and his travels. But there were also lay people that were beginning to make money and become somewhat wealthy and independent, maybe a growing middle class. And there were lecture halls that were springing up, and there were magazines being produced, like similar to the Scientific American or Popular Science. One of the lecture halls was, I believe, called the Athenaeum. And it was popular for people to give scientific demonstrations. You might have electrical experiments, or magnetism and electricity, all kinds of different things, and people would attend these lectures. And people would go on a circuit traveling around England giving lectures on their field of interest and their ideas, their unique, novel ideas. If I knew more, I might do the same on my health ideas, like the new germ theory of disease or the real cause of tooth decay. So Robotham went by the name Parallax, and he went on all these lectures. He actually became quite popular and a household name at that time because people would discuss his ideas. And if you don't know the history, you wouldn't have thought that. But it was a phase that had its place in history. Many things go on in the world all the time, and different topics and different people rise and become popular, and he was one of them in his ideas at that time. Robotham put out a book called Zetetic Astronomy, and he put forward the idea of the Earth being laid out on a disk with the North Pole in the center and the South Pole at the circumference. And there were other flat Earth writers at that time, or perhaps later, that followed him. I believe there's a book called Terra Firma that goes back some time. Now, there are a few things that Robotham did not know, like he did not know that if you aim a telescope at the North Pole star, also called Polaris, that you would see it make a perfect circle around the celestial North Pole. He thought it just rose and fell, whereas it did more than that. It made a tiny little circle. Now, Robotham had a admirer or fan that was a book printer named William Carpenter, and William Carpenter did some kind of book like 100 Proofs that the Earth is not a globe, and used some of Robotham's ideas. He published a challenge that he was willing to bet somebody money that he could duplicate Robotham's experiments on the Bedford Level Canal that was in the region of Bedford, where there was a long flat canal for 5 or 10 miles, some length of distance, where you could see across the top of the canal without the Earth creating an intervening hump. And Alfred Wallace, who was a rival of Charles Darwin, who came up with the concept of natural selection to understand how the genes in a population will be selected for survival of a species and be propagated that way. You'll find that Charles Darwin was part of the wealthy elite, maybe, whereas Alfred Wallace was a poor person who went to school and became wealthy and an expert in his field. So there was a little bit of a class distinction between Darwin and Wallace, and Darwin may have been involved with secret societies as well, and kind of the elitism of those who are in positions in power in science. So maybe it's possible that Alfred Wallace actually came up with the theory of natural selection before Charles Darwin, and Darwin copied it or plagiarized it. There might be a similar situation with Sir Isaac Newton, that he was kind of involved with the elite in the secret societies and in the power regions of social influence. And Leibniz came up with a working theory of calculus, and perhaps Sir Isaac Newton plagiarized that and modified it. Certainly he was a smart man in his own right, and I don't know if that's at all the case, but it's a possibility. There was, in those early days, some kind of club that was formed by the educational elite that was like maybe called the X Club or something like that. I don't know. But they came up with ideas for what they thought science should be, and they directed the direction of education. You see censorship in and oppression in academia today, like if people go against prevailing scientific ideas, even though what they have to say is scientifically sound, that they will face persecution for their ideas. I believe there's a movie called Expelled that talks about people that have ideas about intelligent design, or things that challenge evolution. People can be under pressure. They might lose their job or be no longer accepted in the scientific community, and their papers rejected by publishing companies, and not get funding for things because the academic heads have an agenda and a narrative that they want to push, and they are able to silence opposition within the scientific community using their positions of power. William Carpenter came over here to America, I believe to Boston, and he published books here. Anyway, William Carpenter and Alfred Wallace actually went with some equipment over to the Bedford level, got in the ship, put some flags up, did this experiment, and the person holding the money for the two determined that Alfred Wallace won the bet and awarded him the money, and William Carpenter kept harassing Alfred Wallace about being a cheat and it not being fair. And then Robotham got upset with William Carpenter and said, "Hey, I'm the smart one here, and you did this without me helping you and making sure things went smoothly, and showed what was needed to be shown." There was a person that wrote a poem and put it on Robotham's grave, and it's quite a touching poem about how great this man was, and I'm sure there's some truth to this. Whatever his shortcomings, he also had some greatness. In America, there was a dark-skinned preacher named, I don't know his name, but he had a sermon, "The earth am flat and the heavens do move," something like that. And he advocated a flat earth, and he was a popular preacher. There was, in the early 1900s, a preacher in Zion, Illinois, which is an interesting city in that it was a lot of people that came together to have one church, and it was heavily religiously controlled early on, and eventually the people of the city got more freedom from the controls of religion. But early on, one major preacher or pastor was Glenn Wilbur Volova, and he put out flat earth material for the Zion, Illinois school, and he also issued a challenge and a money reward, I believe, for anybody that could prove the earth was a globe. And he had a lot of money, and I believe he had a yacht and was able to make a trip around the world. But he may not have retained his popularity, or his successor may not have retained the same popularity. And he had a radio broadcast, so he was kind of like a figure from history who had a unique place as a major radio preacher, and his radio waves reached all the way to Australia. They were of a frequency or a wavelength such that, and of a wattage or a power level that they were able to reach all the way over there. There was in South Africa a few people that had flat earth leanings, and in Australia as well, maybe Australia as well. You had the V2 rockets, the first rockets that were able to go up real high and take photography. And the rocket scientists, who were German scientists, they were kind of possibly involved in the occult secret societies, as were many of the people here in America, in the wealthy families, and it was almost a brotherhood, and a lot tied in with the Jesuits. They're powerful models. They're a powerful secret society that has a hand in a lot of other secret societies. The Jesuits are part of a counter-reformation, and they have a lot of intellectuals, and so they're involved in they were in history involved in exploration and astronomy, and they may have done a lot of cover-up in their position of true history. But they went to Japan and South America, China. Now, early on, there may have been many Jews which joined the Jesuits, so it may have a Jewish influence behind it. But you learn a lot about cosmology when you study the flat earth, like what were Galileo's ideas, and then what about Tycho Brahe and his idea for a round globular earth, but centered in space and everything else moving around it. That model actually works with what we observe, because everything's relative. So if you were to have a working model of the solar system and of the stars, and you were to run it with a computer program, and then you were to lock the earth in place and let everything else continue on its relative paths, then they would swirl around the earth, and they would still hold their same relationships one to another. And that's an argument for the possibility that the earth is a sphere but is not moving through space. And early 1900 experiments were starting to show that if the ether exists, then the earth is not moving through space, because the telescope pointed at a star can see that star, but when you fill the telescope with water, water slows down light, and so if the Earth was spinning in some way, the light would be deflected away and you wouldn't be able to see the star. But in the experiment, you can see the star, and so that implies that the telescope is fixed in space and the star is moving across this night sky, and wherever it shines its light, the light's coming just straight down the telescope tube, and there's no relative motion to either. It's just that the star is passing overhead, and as it passes overhead, it's shining its light. That might have been the Michelson-Morley experiments, and there may have been other experiments too, I believe, that were also indicating that the Earth is fixed if there's an ether. And then Einstein came along with relativity, and there may be some problems with relativity, like if you travel away from a place and then you travel back. I don't know. There's some relativity paradoxes that people think they found, which shows that there is a contradiction in its teachings. Now, I believe the concept of spiral galaxies was actually derived before we saw one in our telescopes, in which case it may be that the spiral galaxies we see are actually just falsified images. But how the idea of spiral galaxies were derived at was that if you were to just look at the celestial sphere, you would see a great band of light of many stars that in the night sky looks like a band of light, a Milky Way, and lactose is related to milk, so galaxy has to do with the Milky Way. The original Milky Way that we can see with our own eyes, which is a band of light making a great circle through the celestial sphere. And a great circle is a full circumference. So like with latitude, the only great circle is the equator. All the other latitudes get smaller and smaller as you go to the poles. But now longitudes, those are great circles, and that pass through the North and South Pole on a globe. But we have a great circle of the Milky Way, and so someone thought, well, that band of light, we may be in the middle of a disk of light, or somewhere within a disk of light, and it's a spiral disk, and then proposed that there may be other such spiral disks out there, and then our telescopes find them, supposedly. And then there's Emanuel Swedenborg, who may have came up with the Nebular Hypothesis first, and nebulous is Latin for cloud, so the idea that everything was gas before gas particles condensed into almost like if you have a bunch of leaves strewn everywhere and then you were to rake the leaves into piles. Well, our universe is matter that's been accumulated into piles, into spheres and things like that. And that's the Nebular Hypothesis. And then eventually a mathematician, Laplace, who has the Laplace transform, he popularized the Nebular Hypothesis. And the distance from the sun is supposedly 93 million miles, and the radius of the Earth 39 miles. The angle of tilt of the Earth's axis 23.4, something like that. The circumference of the Earth 24,000 miles. The rotation of the Earth in one day, 24 hours. And so the Earth at the equator traveling at 1,000 miles per hour. These are some interesting things that you'll learn from studying flat Earth. So it's a knowledge building adventure of discovery with a lot of drive that people can get behind it because they're interested and want to know. And then that sparked interest leads to diligent and involved and interested study. I used to say that Operation Paperclip brought over Nazi scientists to work with their American CIA secret society brothers or friends, and that they came over to fill two positions, space travel and mind control, with the MK Ultra program. But I've recently come to realize that there was a third scientific study that was being conducted, and that was on biological warfare with germs or with toxins and chemicals, or harmful chemicals. So maybe those three areas were filled by a German Nazi influence. And actually, there's a documentary, JFK to 9/11, Everything is a Rich Man's Trick. He does a real good presentation. I don't know if everything in it is true. There may be some things he's missed, and some characters who were involved that would have more to say, and more story could be built up about them. But and also his idea that communism, he didn't realize that even communism was funded out of New York by Jewish agitators that left New York to Russia with a bunch of gold to bring about the communist revolution, and that many of the top communists were Jews at that time. Even though the Russians may have greatly persecuted Jews. And you'll learn a lot about NASA and maybe some trick photography that they use. There's an airplane that can fly up real high, and then not fly high anymore and just let itself drop, and then everybody inside the airplane for a minute or two have a weightlessness, but in the room they're moving relative to it, and so they can do weightlessness experiments until the airplane pulls out of its dive and starts to climb back again, and then people have to find a place to anchor themselves until they're ready for the next demonstration of free flight. And people's hair in the ISS, women's hair, may not really model what hair would look like in a weightless environment, because it may be hairsprayed in order to not come down when the airplane ascends back up. Whereas if you're in water, for example, a woman's hair in water moves fairly freely, or if a woman tosses her hair, you can see that it without gravity on it, it might go all over the place, or it might be more fluid and whip around and stuff, just from a slight shaking of the head. But maybe some of the NASA photographs are faked. They had gotten the moon landing missions and the Apollo missions very well rehearsed, and they were doing simulations that had gotten so good that whoever's in charge of the simulation could say, this is a true test, and then run the simulation, and none of the people at their consoles would know that they're just participating in a simulation. And maybe a famous movie producer that was involved with helping do the trick photography and choreograph the moon landing narrative. There's Admiral Byrd, Byrd, that led an Army or Navy expedition to the North Pole, but also to the South Pole, and and some of his observations. I think he mentioned that in Antarctica, somewhere south, there's actually some warm areas where maybe there's a lake, and he talked about a continent, a large unexplored area with great resources, which would either be the continent of Antarctica or some continent beyond it. And I like the extended flat Earth map because it would allow for people to, once they're ready to leave this world and begin to populate other lands further out, and perhaps without ending. And I would still hold to the Bible idea of revelation, whatever that says, but depending on your interpretation of it, it does not necessarily stop you from being able to have the world as we see it now, with all the people that we have now, just continue to grow and expand and begin to populate other continents beyond the South circumference. Well, thank you for your time. That's probably it on the Flat Earth parts 1, 2, and 3, although similar to my video challenging the existence of atomic bombs, I may do a video challenging the existence of satellites.